We now look at what's called the rate equation for a linear function. The average rate for any linear function, the delta y over delta t that we get, and that's what we mean by the average rate, for example, change in depth over change in clock time. That average rate is always the same for a linear function. That means we always have the same slope. Delta y over delta t is the slope, and a linear function always has a graph that has the same slope, so it always has the same rate of change. So that by expressing the average rate equation, delta y over delta t equals constant, we characterize the linear functions. So every linear function has this rate equation. The rate equation is written dy over dt equals constant. Instead of using deltas, we use d's. And this is regarded as giving us the instantaneous rate of change at any point, as opposed to an average between 2 points, the absolute instantaneous rate at any given point. And of course, for a linear function, that's still always going to be constant. So for future information, we call this dy over dt equals constant, the rate equation. You understand the average rate equation. In calculus, you learn the specific meanings of these terms dy and dt, but you can understand that if we replace delta by d, this is what we get. And another thing that you can store away if you plan to take calculus. If not, you can skip this part, but it's only going to last a few seconds, so don't worry about it. This is what's called a differential equation. This expression here is called a derivative, and an equation that involves rates expressed as derivatives is called a differential equation. Again, you don't have to know that, but if you're going to take calculus, store it away. It'll help you later.